Good afternoon, scientists. Welcome back. If you're feeling a little squirrely today, it's a good day for it, because by the time you see this, it will be Friday. But we do have one more unit to cover before you can go off and play Fortnite, or whatever it is you guys do when I'm not looking. So let's jump right into that. We are leaving the unit on DNA and replication. Remember, that was Life Science Standard 3. Right, we're moving on to Life Science Standard 4, which is a set of 4 standards on evolution and natural selection. All right, so evolution was created by this man, Charles Darwin, who came up with the theory of evolution. We see him here as a young man. He would eventually go on to grow a amazing wizard's beard. It's a shame he doesn't have it in this picture, but we'll talk about that in class. All right, but before we can talk about the theory itself, we have to talk about some terminology. All right, so first one is evolution. Evolution is a word used in common parlance for anything that changes over time, which is exactly what it means. It's a process of change over time. But when we're talking about time in biology, we're talking about a lot of time. Evolution is something that would take place over hundreds of thousands to millions of years. Okay, so extremely long periods of time. And as we've already discussed, a theory is a well-tested explanation that covers a lot of observations. All right, so here we see an example of the progression on the discovery of microorganisms and bacteria, starting with Francesco Redi's discovery that maggots don't live in meat. They're actually left there by flies, and that if you cover it, they won't get them, which is good, all the way to the discovery of pasteurization and microorganisms themselves. So for those of you who have milk with your cereal in the mornings, you have Louis Pasteur to thank for not getting food poisoning every other day. Right, so this is an example of the development of a theory over time. All right, so Charles Darwin was what's called a naturalist. He was born in 1809, and he graduated from Cambridge University in 1831. He commissioned this ship, the HMS Beagle, right, to sail around the world with him. It took quite a bit of time, as you can see. Sailing vessels aren't the fastest ships, and he spent a lot of time in the Galapagos. So about 5 years at sea to sail around the world one time. Then he came back, he compiled his notes. He actually worked with another naturalist who did similar observations in Indonesia. And in 1859, he published his greatest work on the origin of species. He would eventually evolve his way out of this world in 1882. So he was influenced by a couple of other people. Now, Thomas Malthus was not a scientist, he was an economist, but he wrote an important essay on populations. It stated that human populations will grow endlessly unless it is prevented by famine, disease, and war. So his position was that there are limited resources, and human population will eventually cause conflict over those resources. We've already talked about Jean-Baptiste Lamarck, right? Because he did seminal work on the inheritance of acquired characteristics, which we talked about last unit in Life Science 3. Here we have James Hutton, who always looks perennial surprised, right? And he talked about the history of the Earth and how its history can only be described by what happens now, which Darwin believed was true of life as well. We can only talk about the history of life by examining life as it is today. And last, we have Charles Lyell, who was a great geologist, and he put forth the theory of uniformitarianism, right, which said that the Earth's crust would change over time from continuous and uniform processes. And Darwin figured if it's true for the Earth itself, it's probably also true for life. So Darwin spent a considerable amount of time in the Galapagos Islands, and he noted that the life there was varied. It was adapted. Right? So different animals had adapted to the specific islands that they lived on. So even though they were all related, they were all a little bit different. So here you see Galapagos finches. Note they are not all the same size. They have different shapes of beaks, depending on what type of food is available on their different islands. Some are good for crushing shellfish, some are good for eating seeds, some are good for catching and eating insects. Same with the Galapagos tortoises. There are several different species of tortoise. Right? Some are very long-legged and long-necked, great for reaching food on top of rocks for those that live on the drier lower islands. some large, heavy, and low for the larger islands with heavy vegetation. Okay, so that's an example of adaptation on ecosystems. And it's also an example of what's called selection. A creature that is best adapted to its environment was more likely to survive and reproduce. So a black moth is more likely to survive in an area with black trees than a white moth is. And we do the same with artificial selection by breeding animals to be sizes that we want and have traits that we want. So adaptation, not always random, right? We do the same as well. So before class, I want you to watch this video on natural selection. It's not that long. It's pretty interesting. I think you'll like it, so that when we start class right at 8 o'clock, we can jump right in. All right? And I will see you then.